intelligent claim agent for AMD Hackathon Track 2. All inference runs on AMD Radeon. W7900 with ROCm, no cloud APIs. JWT bearer authentication. SHA-256 salted hash, JWT issued. All inference local. Multi-term memory, no re-extraction needed. Answers from cached RAG result. Landgraph session memory, recalculates from stored context. UUID session isolation. Upload invoice. The agent executes a 4-step pipeline. Step 1. Multimodal OCR. vLLM extracts fields from image. Step 2. Verification. Cross-check against official tax API. Step 3. RAG retrieval. Trauma plus BGA on GPU 3-tier. Exact match sympanic search. Threshold for out-of-catalog. Step 4. Deterministic decision. Pure code rules. Every amount auditable, not LLM generated. Now we're showing batch processing. The pipeline demonstrates various capabilities, such as tool calling multi-step planning and RAG. Beyond claims, insurance companies have another critical high-volume workflow: underwriting. Every application requires reviewing medical reports, detecting lab abnormalities, scoring disease risk, and searching medical literature, tasks that are repetitive, manual, and error-prone. We built a second agent specifically for this. Both run on the same AMD GPU. Meet the Underwriting Risk agent. SIM architecture. 4 tools: medical report extraction, abnormality detection risk scoring, and dual backend medical research search. Independent pipeline. Independent memory. SIM embed Radeon GPU. 2 agents for the 2 most repetitive departments in insurance together. The claims agent and underwriting agent cover the full insurance value chain. All local, all private, all on AMD. Live benchmarks on the W7900. MTP speculative decoding delivers 50 tokens per second with a perfect 100% draft acceptance rate. Embedding GPU migration achieves an impressive 92.5 times speedup. 10 GPU optimizations, all measured on this hardware. Full AMD ROCm pipeline. Low rank adaptation fine-tune GGUF quantize. Inference on AMD device. Full AMD pipeline, all local, all private, all auditable.
AMD AITER library officially lists this card, the W7900 ARNA 3, as experimental, but vLLM's integration layer never exposed AITER here. It only enabled AITER on data center CDNA 3 and ARNA 4. ARNA 3 fell in the gap, so every AITER kernel silently fell back to emulation. We closed that gap in 4 source changes. The architecture gate, the arch allow list AGFX1100 tuning config, and a WAMA kernel root. Log confirms AITER int 8. Scaled linear kernel is live. First working AITER path in vLLM on consumer RDNA 3 and upstream vLLM still doesn't have this. Same pipeline, we lifted vLLM from 9 to over 12 tokens per second, plus 30%, removing FP8KV software emulation that our DNA has no hardware for it. Our fine-tuned 9B runs on a 48GB workstation card at 61 tokens per second, but it also runs on a consumer ARC 6800 XD 16GB at 23 to 30 tokens per second. Same model, same prompts, different GPU generations RDNA 3 to RDNA 2. This is what makes the agent deployable on consumer Radeon hardware, not just workstations.